All right, so in this next video, we're working with another really essential skill in algebra, which is factoring. So when we have a polynomial, if we want to try to factor this polynomial, the very first thing we should be looking for is a GCF, or a greatest common factor. Okay, a little bit more about that in a minute. After we look for the GCF, the next thing that I want to know is the polynomial I'm trying to factor a trinomial. Trinomial, remember, means three terms, right? Trinomial. And so one of the ways that we can factor a trinomial, if it is in fact a trinomial, is if my leading coefficient is 1. That's that double bubble method that we talked about. So in that case, I'm looking for two numbers that add up to, that multiply to c and add up to b, assuming that we're in standard form, meaning it looks like ax squared plus bx plus c. Okay, the a, again, in this case, would be a 1. So two numbers that add to the middle coefficient and multiply to that third term. Now, if it just so happens that I have a trinomial but that leading coefficient is not 1, that's when we bring up the AC method. Okay, so again, that's going to be a trinomial when a is not 1, that leading coefficient. And it's called the AC method because we're going to start by multiplying a times c. Okay, so these are sort of the list of types of factoring we want to run through. We also want to keep in mind some special factors or special products. Okay. If I see something that looks like either one of these two patterns, a squared minus 2ab plus b squared, or a squared plus 2ab plus b squared, then this could be a perfect square trinomial. Okay. And again, the key to noticing these are the first and last terms will both be perfect squares, and the middle term will be double the square roots of the outside terms. Okay. The last kind of special factor, or special product, is if you imagine foiling these two terms together, a minus b times a plus b, what we're going to get is a squared minus b squared. Okay, so this should look familiar. It's what we call the difference of two squares. Difference because we have that minus sign in between the two terms, and squares because you'll notice the first and last terms are perfect squares. And so when I see something that looks like that, that's a difference of two perfect square terms, I know that I can factor it into two binomials this way. So here's some examples of trying to factor. Now, first thing is factoring out the GCF. GCF, we should remember, stands for greatest common factor. Greatest common factor. And that's exactly what I'm looking for. I'm going to look through my however many terms I have, and I can do this with any polynomial, no matter how many terms there are. And I want to find a common factor among my terms. So for example, in example A here, if I'm looking at my two terms, we can start with the coefficients. I've got 18 and 12, so a common factor among those would be a 6. I also have an x from the first term and an x squared, so my common factor is x, and a y to the third and a y, so my common factor is y. Now, when I factor out a GCF, then what I want to try to do is actually divide each term by that GCF, so I can figure out what's going to be left after we pull it out. So I'm going to divide. 18 divided by 6 is going to give me a 3 from the first term. My x's here are going to cancel, and y to the third divided by y will give me y squared. Okay. Then in the second term, minus 12 divided by 6 is 2, x squared divided by x is x, and my y's here cancel. So you should have two parts when you factor out a GCF. You should have the GCF itself on the outside, and then what's left inside the parentheses afterwards. Okay. Next thing we're going to do is factor fully, okay, or sometimes you'll see factor completely. Factor completely, meaning that you may have to factor each thing more than once, so you want to be on the lookout for that. Okay. Letter A here as an example. So I'm looking for a GCF first. We always want to look for a GCF first, but there aren't any common factors among these three terms. There are three terms, however. It is a trinomial, and because I notice that this leading coefficient is 1, I know that I can factor this using that double bubble method. So I can open up two sets of parentheses. Okay. And because this first term was an x squared, I know I'm going to have to multiply x times x in my first terms in order to get that. So we're on a good place there. And now I want to know two numbers that will multiply to the third term and add together to be the second coefficient. So I want two numbers whose sum is -7 and whose product is 12. Okay, so we're multiplying to a positive number. That means that my two factors have to have the same sign. They both have to be positive or both have to be negative. And they're multiplying to 12 and adding to -7. So if I think about it for a minute, the two numbers that add to -7 and multiply to +12 are going to be -3 and +4. So these are the two numbers that go inside the parentheses. Okay, moving right along. Letter C here, this example. What I'm seeing here is that I've got a trinomial again, and I want to try to factor out a GCF, but again, there's no common factor here. So I can't factor out a GCF. What I have to do then is AC method. Okay, so I am going to start by multiplying the first and last terms together. 2 times -20 is going to give me a -40. And for this, we start out kind of in the same way as the original trinomial problem. I want two numbers whose sum is -3, that middle coefficient, but now I want a product of -40, okay, that product of A times C. So two numbers with a sum of -3 and a product of -40 are going to be -8 and +5. And these are my two factors. But now, instead of opening up two sets of parentheses, what I actually want to do is split up that middle term. So instead of -3y, I'm going to write -8y plus 5y. Okay, still a 3y, -3y, but I've just split it up into two separate terms. We can still bring down the outside terms. They're still there, 2y squared minus 20. And now, if you remember, I want to split this down the middle and factor out a GCF on both sides. So for my first two terms, 2y squared minus 8y, I can factor out a 2y. And that's going to give me 2y times y minus 4 when we factor out that GCF. On the right, I can factor out, looks like a 5. So if I factor out a 5, I have 5 times, again, y minus 4. Really, really important that these two binomials match, okay? This will only work if the two binomials match. And what happens now is I've got sort of two terms here, 2y times y minus 4, and then 5 times y minus 4. So I can factor out the y minus 4, and what I have left is 2y plus 5. So that's an example of factoring with the AC method. And again, as I've been saying before, you want to make sure that we're factoring completely. So I do want to check my factors at the end and make sure there's nothing else I can pull out. No more factoring I can do, no extra GCF. Okay, so far so good. In this example letter E, I'm looking at it, I see two terms, and I definitely see a GCF that I can pull out. I see a factor of 2. So if I divide by 2, I've got now x squared minus 36. Okay. But what I'm noticing is that I've got more factoring I can do. This x squared minus 36 is the difference of two squares. Okay, it's a difference. I see a minus sign. There are two perfect square terms, and so I can factor this. So the way we factor difference of two squares, I take the square root of the first term. So the square root of x squared is going to be x. The square root of the second term, square root of 36 is 6. And one of those is going to be a positive, and one of them is going to be a negative. So that's the factors of x squared minus 36. Now don't forget also, if you have any additional factors, they have to stay in there as your final answer. Okay? Now I know I skipped some, so what I'd like you to do at the end of this video is go back and actually try those problems on your own, and we'll go over the answers tomorrow in class. Now that we remember how to factor, we can talk about solving quadratic equations. Now, if I have an equation, I want to make sure it's in standard form. Standard form, if you remember, looks like this: ax squared plus bx plus c equals 0. Okay? And if I'm going to solve by factoring, I want to factor the left side and then set each factor equal to 0 and solve. Now, if I can't factor, then we're going to have to use the quadratic formula. So as a reminder, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's your quadratic formula. Okay. So these first two example problems I want to solve by factoring. So I'm going to do example B with you. Example B, so first thing I want to do is put it into standard form, okay? Means everything on one side of the equation. So I'm going to add 2x, and I'm also going to add 1 on both sides. So my whole right side's going to cancel, and we have x squared plus 2x plus 1 equals 0. Okay. So now I can factor. So I have a trinomial. I'm looking for two numbers whose sum is 2 and product is 1. And the only two numbers whose product is 1 and 1, and the sum is in fact 2. So that'll work for me. So we got a double bubble method here. Okay. X in the first two spots and plus 1 plus 1. If you notice, this actually was also one of those special products. The x squared plus 2x plus 1 is a perfect square in the first and last terms, and the middle term is twice the product of those two square roots. So we could have used a special product there. Okay. So now that I've got this factored, I want to take each factor, although I only have to do it once in this particular case because they're both the same, and I want to set them equal to 0. So x plus 1 equals 0, and so that's going to give me my solution, which is just x equals -1. Okay. Now, in the end here, solve by using the quadratic formula. Okay. So again, I do need to start by getting everything into standard form. So in this case, in the first problem, letter A, I'm going to move everything to the left side. So we've got 6x squared. To subtract 29x on both sides, and then add 9 to both sides. Okay. So now we're in standard form. And so if you want, you can just kind of take note. A here is 6, the coefficient of the x squared. B is -29, the coefficient of the x. And C is 9. And so I'm going to plug that into the quadratic formula. Okay. So quadratic formula says x equals -b, so -29, plus or minus the square root of -29 squared minus 4 times a times c all over 2 times a. And now all I have to do is kind of simplify here. So we've got x equals -29 is a positive 29, plus or minus the square root. Now -29 squared minus 4 times 6 times 9, if I take that whole thing inside the radical, we're going to have 625 all over 2 times 6, which is 12. Now, in this particular case, 625 is a perfect square, so that reduces to just 25. Okay. If it wasn't a perfect square, you would have to simplify that radical. All over 12. And now, because these two terms happen to be like terms, I do need to split up and figure out what my two solutions are. So two solutions, because we have that plus or minus, so I have 29 plus 25 over 12, and 29 minus 25 over 12. So simplifying this, 29 plus 25 over 12 is going to be 54 over 12, which reduces to 9/2. And 29 minus 25 over 12 is 4/12, which reduces to 1/3. So here are my two solutions, 9/2 and 1/3. Okay. And again, I want you to go back and just practice doing the couple of problems that we did not do, and we'll go over the answers to those in class tomorrow.